Welcome, fellow dreamers and seekers of cosmic truth. Tonight, we embark on a journey that will reshape everything you thought you knew about human history. As you settle into comfort, let your mind drift beyond the boundaries of Earth, beyond the familiar blue skies and green landscapes. Tonight, we explore a possibility so profound, so earth-shattering, that it challenges the very foundation of our existence. Imagine if I told you that the story of civilization didn't begin on Earth at all. Imagine if long before our first cities rose from river valleys, long before our ancestors walked upright across African plains, another world already carried the weight of advanced societies, towering structures, and perhaps even love, loss, and dreams under a crimson sky. That world is Mars, and if this is true, if civilizations once flourished there, then everything we believe about our origins is merely the continuation of something far more ancient and mysterious. Close your eyes for a moment. Picture Mars not as the cold, barren desert we see today, but as a vibrant world teeming with life. Rivers flowing through valleys, cities rising from fertile plains, beings gazing up at two small moons, and dreaming of the bright blue star hanging in their night sky. The same star we call home. This isn't science fiction. This is a scientific possibility, supported by growing evidence, controversial theories, and questions that keep researchers awake at night. Before we're done, you'll understand why some scientists whisper about this theory in hallways, why certain discoveries are quietly debated, and why the implications are so staggering that accepting them would rewrite every history book on Earth. Stay with me until the very end, because what we uncover tonight changes everything about who we are and where we truly come from. And I promise you, by dawn, you'll never look at the red dot in our sky the same way again. But first, let me ask you something that might seem simple. When you look up at Mars with the naked eye, what do you feel? Most people see just another star. But what if that feeling of familiarity, that strange pull you might experience, isn't random at all? What if it's the deepest kind of recognition? The recognition associations. Every culture that observed Mars also sensed something else. Something almost familiar. Think about this for a moment. If you were an ancient astronomer watching the night sky, you'd notice that Mars behaves differently from other planets. It brightens and dims in cycles. It appears to move backward at times, creating loops against the stellar background. Most intriguingly, even through primitive telescopes, observers could see changing features, dark patches that shifted with seasons, polar caps that grew and shrank, and mysterious linear markings that seemed almost too organized to be natural. By the late 1800s, serious astronomers like Giovanni Schiaparelli and Percival Lowell were convinced they could see vast canal networks crisscrossing the Martian surface. Lowell spent decades mapping what he believed were irrigation systems built by an advanced but dying civilization. He imagined Martian engineers desperately channeling water from melting polar caps to sustain their cities as their world slowly dried up. Now, we know these canals were optical illusions, tricks of light and shadow playing with human perception. But here's the haunting part. The core idea wasn't entirely wrong. Recent discoveries have revealed that Mars once had vast river networks, lake systems, and possibly even oceans. The illusion of canals may have been our subconscious recognition of what Mars had actually lost eons ago. What if our ancestors' obsession with Mars wasn't just astronomical curiosity? What if some deep, genetic memory was stirring? An ancestral recognition of a world that once meant everything to our forgotten past. Consider this unsettling possibility. Every human culture independently developed myths about beings descending from the sky. The Sumerians spoke of the Anunnaki. The Hindus described the Vimanas. Native American traditions tell of star people. African cultures preserve stories of visitors from celestial realms. What if these weren't myths at all, but cultural memories of our own origins? Stories passed down through countless generations about the world we left behind. Modern lifeless world. Before you write this off as fringe science, consider that mainstream researchers are increasingly willing to discuss these anomalies. Dr. John Brandenburg, a plasma physicist with NASA and the Department of Defense, has published peer-reviewed papers suggesting that Mars may have experienced nuclear catastrophes. Dr. Richard Hoover, a NASA astrobiologist, has identified what he believes are fossilized microorganisms in Martian meteorites. The question isn't whether these scientists are right or wrong. The question is, why are credible researchers even considering such possibilities? What evidence are they seeing that makes the impossible seem plausible? As you drift deeper into tonight's exploration, remember that science's greatest discoveries often began as heretical ideas. The notion that Earth orbits the Sun was once considered ridiculous. The theory of continental drift was mocked for decades. The existence of black holes was pure speculation until recently. What if the idea of Martian civilizations is following the same path from impossible to inevitable? Take a moment to really consider what we're discussing here. We're not just talking about microbes or simple life forms. We're exploring the possibility that an entire world once thrived with complexity, intelligence, and perhaps even love, art and philosophy, all erased by cosmic forces beyond their control. If this is true, then Mars isn't just another planet to explore. It's the greatest archaeological site in the solar system, holding secrets that could revolutionize our understanding of life, consciousness, and our own identity as a species. And this brings us to our next profound question. What would a living Mars have actually looked like? How different was this world when rivers flowed freely and life had a chance to flourish? Chapter 2. When Mars was Earth's twin. Close your eyes and imagine stepping onto the surface of Mars 3.5 billion years ago. Instead of the rust-colored desert you expect, you find yourself standing beside a vast, shimmering lake. The water is crystal clear, reflecting not one but two small moons racing across a sky that's not quite blue, but not quite red either. A unique hue that would become Mars's signature color only after eons of oxidation. This isn't fantasy. This is Mars as it might have contained. Think about the scale of water that once existed on Mars. Scientists estimate that the northern lowlands could have held enough water to create an ocean covering nearly a third of the planet's surface. We're not talking about puddles or streams. We're talking about vast bodies of water deeper than many of Earth's seas. The Hellas Basin alone could have contained a lake larger than the Mediterranean Sea. But here's what makes this even more extraordinary. This wasn't just water sitting stagnant on the surface. Mars had a complete hydrological cycle. Clouds formed in its thicker atmosphere. Rain fell on ancient continents. Rivers carved through landscapes, creating the same meandering patterns we see on Earth. Seasonal changes caused water levels to rise and fall, leaving behind the terraced shorelines we can still observe today. The mineral evidence tells an even more compelling story. Mars rovers have discovered extensive clay deposits, materials that can only form through long-term interaction with liquid water. These aren't brief, violent encounters with moisture, but sustained periods of gentle weathering that suggest stable climatic conditions lasting millions of years. Even more intriguing are the sulfate deposits found in various regions. On Earth, these minerals form in environments where water repeatedly evaporates and returns. Exactly the kind of conditions you'd find around the edges of lakes and seas that fluctuate with seasons or longer climate cycles. This suggests that Mars didn't just have water, it had stable bodies of water that persisted long enough for complex chemical processes to unfold. Now here's where conventional science meets controversial possibility. If Mars had stable water, moderate temperatures, and a protective atmosphere for millions of years, it had everything necessary not just for life, but for life to evolve into complex forms. On Earth, life appeared relatively quickly once conditions were right, but complex multicellular organisms took billions of years to develop. Mars may have had that time. In fact, some evidence suggests Mars became habitable before Earth did. While our planet was still being bombarded by asteroids during the late heavy bombardment period, Mars may have already been developing its first ecosystems. This raises a profound question that many scientists are reluctant to discuss publicly. Relatively short time. If Mars had twice that much time, or 3 times that much time, the possibilities become staggering. Consider this. Mars had lower gravity than Earth, which would have allowed for different evolutionary paths. Flying creatures might have evolved earlier and grown larger. Tall, spindly plants might have reached incredible heights. Even large animals could have moved with an ease impossible on our heavier world. The unique Martian environment would have shaped life in ways we can barely imagine, with 2 small, fast-moving moons creating complex tidal patterns. Marine life might have evolved sophisticated timing mechanisms. The longer Martian day, about 37 minutes longer than Earth's, might have influenced biological rhythms in ways that created entirely different metabolic systems. But perhaps most significantly, Mars's weaker magnetic field meant that surface life would have been exposed to more cosmic radiation. This might sound harmful, but radiation also drives mutation rates. Life on Mars might have evolved faster, developing protective mechanisms and adaptive strategies at an accelerated pace. What would Martian forests have looked like? Without abundant oxygen, they might have been dominated by different types of plant life, perhaps organisms that used different photosynthetic chemicals, creating landscapes painted in purples and deep reds rather than greens. Some researchers have even suggested that chlorophyll-based plants might not have been optimal on Mars, opening the door for entirely different approaches to converting sunlight into energy. And if plant life existed, what about the creatures that might have depended on it? Mars's lower gravity would have allowed for animal forms impossible on Earth. Imagine creatures that could leap incredible distances, or flying animals that could soar for days without landing. The reduced atmospheric pressure might have favored organisms with different respiratory systems, perhaps more efficient oxygen processing that would have made them incredible athletes by Earth standards. Now I know what you're thinking. Where's the evidence for all this complexity? Why haven't we found obvious fossils or clear signs of advanced ecosystems? The answer lies in Mars's tragic transformation from a living world to a dead one. What happened to Mars wasn't gradual decline, it was catastrophic loss that erased nearly every trace of what came that water had nurtured for eons. The evidence for ancient Martian oceans isn't subtle. It's written across the planet's surface in features so obvious that even early astronomers sensed something was different about this world. But it's only now, with high-resolution satellite imagery and sophisticated analysis, that we're beginning to understand the true scale of what Mars has lost. In the northern lowlands of Mars, orbital photographs reveal what can only be described as ancient shorelines. These aren't random geological features. They're the kind of smooth, curved boundaries that form when water meets land over thousands of years. The Arabia Terra region shows multiple levels of what appear to be ancient beaches, suggesting that water levels rose and fell multiple times, just as they do on Earth during ice ages or climate shifts. But here's what's truly astounding. These shorelines suggest that Mars once had an ocean that would have been deeper than the Arctic Ocean and covered an area larger than the Atlantic. We're talking about a body of water that would have been visible from Earth if you could have looked at Mars 3 billion years ago through a powerful enough telescope. The Northern Ocean wasn't alone. Scattered across Mars are hundreds of impact craters that show unmistakable signs of once being filled with water. Gale Crater, where the Curiosity rover operates today, contains layer upon layer of sedimentary rock that could only have formed underwater. The patterns in these rocks tell stories of calm, deep water that persisted for millions of years, long enough for fine particles to settle into the precise geological patterns we see today. Even more compelling is the discovery of what scientists call inverted channels, raised ridges that snake across the Martian landscape in patterns identical to river systems. These features formed when flowing rivers deposited harder minerals along their beds. After the water disappeared, wind erosion wore away the surrounding softer rock, leaving the old river channels standing above the surface like fossil highways, marking where water once flowed. But the most haunting evidence comes from a region called the Chryse Planitia, where both Viking 1 and Pathfinder landed. The landscape there is covered with what geologists call catastrophic flood deposits. Massive boulder fields, carved channels, and debris patterns that could only have been created beneath thick ice caps, suddenly finding channels to the surface and erupting in floods that briefly brought Mars back to life. This raises a disturbing possibility. Mars didn't die gradually. Its transformation from a water-rich world to a desert may have been punctuated by catastrophic events that would have been devastating to any life forms that had evolved there. Now, here's where the story becomes controversial. Some researchers have identified features in these flood deposits that don't fit conventional geological explanations. Dr. John Brandenburg, the plasma physicist we mentioned earlier, has pointed to spherical particles in Martian soil that are typically associated with nuclear explosions. He's also noted unusual isotope ratios in the Martian atmosphere that mirror what we see after atomic weapons testing. Brandenburg's hypothesis is startling. He suggests that Mars may have experienced nuclear catastrophes that contributed to its atmospheric loss and the evaporation of its oceans. Whether these were natural phenomena, perhaps massive meteor impacts that triggered nuclear reactions in uranium-rich deposits, or something else entirely, remains a matter of intense debate. But let's step back from controversy and focus on what we know for certain. Mars had oceans, rivers, and lakes for extended periods. The chemistry was right for life. The temperatures were suitable. The pressure was adequate. If life exists wherever these conditions are met, as it seems to on Earth, then Mars should have been teeming with organisms. So where did they go? The conventional answer is that they never existed in complex forms, or that they were too fragile to leave fossil evidence. But there's another possibility that researchers whisper about in conferences, but rarely discuss in published papers. What if life on Mars didn't just fade away, but was forced to adapt in ways we haven't yet learned to recognize? Consider this. On Earth, when environments become hostile, life doesn't always die out. It goes underground. Entire ecosystems exist in deep caves, in underground rivers, and in spaces between rock layers where conditions remain stable, even when surface environments change dramatically. Mars today may appear lifeless on the surface, but beneath that red dust could lie the most extensive underground biosphere in the solar system. Recent discoveries of liquid water beneath Mars's polar ice caps suggest that intriguing thought. What if some Martian life didn't retreat underground, but found another way to survive the death of its world? What if it found a way to leave Mars entirely? This brings us to one of the most controversial and fascinating theories in astrobiology: the possibility that life from Mars found its way to Earth, carrying with it not just the seeds of biological existence, but perhaps even the foundations of intelligence itself. If this is true, then we aren't just related to Mars. We are Mars, transplanted and transformed, but carrying within our very DNA the memories of a world we've forgotten. Chapter 4. Whispers in the Martian Wind. There's something unsettling about the silence of Mars. When our rovers record audio from the Martian surface, what we hear isn't the absolute quiet of space, but something more haunting. The whisper of wind across empty landscapes that seem to echo with the memory of voices that no longer exist. This silence becomes even more mysterious when we consider the growing body of evidence suggesting that Mars wasn't just inhabited by simple microbes, but may have supported complex ecosystems that vanished so completely that we're left with only the faintest traces of their existence. The search for life on Mars has revealed discoveries that challenge our understanding of what constitutes evidence of biological activity. NASA's rovers have found organic molecules in Martian rocks, not just simple carbon compounds, but complex chains that, on Earth, are associated with biological processes. The Curiosity rover detected methane in the Martian atmosphere that appears and disappears in seasonal cycles, behavior that's difficult to explain through purely geological processes. But perhaps most intriguingly, there are the spherules, tiny, perfectly round particles scattered across the Martian surface that some researchers believe could only have been formed by biological processes. These blueberries, as scientists nicknamed them, display internal structures remarkably similar to fossil bacteria found in Earth's oldest rocks. The conventional explanation is that these features resulted from chemical processes involving water and minerals. But a growing number of researchers are questioning whether we're applying Earth evolved more rapidly or along different pathways than terrestrial biology. This raises a profound question. If Mars supported life forms more advanced than early Earth's organisms, what happened to them? Why do we find only microscopic traces when the planet's early conditions should have supported much larger and more complex ecosystems? One possibility is that we're looking in the wrong places. Most of our Mars exploration has focused on areas that were once wet, assuming that water equals life. But what if Martian life evolved strategies for survival that didn't depend on surface water? What if the most successful organisms were those that learned to live in environments we haven't yet learned to explore? Recent discoveries have revealed that Mars has extensive cave systems, many of which extend far deeper than we can currently probe. These underground networks might have provided stable environments where life could persist even as surface conditions deteriorated. The Martian subsurface may contain ecosystems that have been isolated for billions of years, evolving in complete independence from anything we've seen on Earth. Even more intriguingly, some of these caves show signs of recent geological activity. Water seepage, mineral deposits, and chemical compositions that suggest active processes are still occurring below the surface. If life exists in these hidden environments, it might be thriving rather than merely surviving. But the implications go beyond simple microbial life. If Mars had stable underground environments for billions of years, evolution might have produced organisms of remarkable complexity. Dr. Penelope Boston, a cave researcher who has studied Earth's most extreme underground environments, has found ecosystems that are completely independent of surface conditions, powered by chemical energy and supporting complex food webs. If similar conditions exist on Mars, and the evidence suggests they do, we might be dealing with a biosphere that's not just alive, but actively evolving. The organisms we eventually discover might be so different from terrestrial life that we initially fail to recognize them as biological at all. This possibility becomes even more intriguing when we consider the timescales involved. Life on Earth has existed for roughly 3.5 billion years, but it spent most of that time as simple microorganisms. Complex multicellular life only appeared in the last 600 million. Weather, seasonal changes, predation. Organisms might have more energy to devote to developing complex nervous systems and problem-solving abilities. This leads to a speculation that few scientists are willing to discuss publicly. What if Mars didn't just support intelligent life, but may still support it today, hidden in deep caves and underground oceans we haven't yet learned to access? The idea seems far-fetched until you consider that we've explored less than 1% of Mars's surface and virtually none of its subsurface. On Earth, we continue to discover new species in deep ocean trenches and underground rivers. Every expedition into previously unexplored cave systems reveals organisms that have been evolving in isolation for millions of years. Mars has had billions of years for such isolated evolution to occur. The organisms we eventually encounter might be so adapted to their underground environment that they bear no resemblance to surface life as we understand it. They might process energy in ways we've never seen, communicate through methods we haven't imagined, and solve problems using intelligence that operates by completely different principles than our own. But there's another possibility that's even more provocative. What if ancient Martian intelligence didn't remain hidden underground, but found a way to preserve itself across the vast stretches of time since Mars's surface became uninhabitable? What if the whispers in the Martian wind aren't just the sound of empty landscapes, but the echo of a message left behind by beings who knew their world was dying? Chapter 5. The Great Silence. What happened to them? If Mars once supported advanced life, or even civilizations, the most haunting question isn't whether they existed, but what caused them to vanish so completely that we're left guessing about their very existence. The Great Silence of Mars may represent one of the most profound tragedies in cosmic history. The death of an entire world and everything it had created. Understanding what happened to Mars requires us to piece together a catastrophe that unfolded over millions of years, but whose effects were so devastating that they erased nearly every trace of complex life from the planet's surface. This wasn't a single event, but a cascade of disasters that transformed a living world into the frozen desert we see today. The first space. As the atmospheric pressure dropped, liquid water became unstable on the surface. Rivers dried up, lakes evaporated, and any life that had evolved in aquatic environments faced extinction. But atmospheric loss was just the beginning. As Mars's atmosphere thinned, the planet lost its ability to regulate temperature. Without a thick atmospheric blanket to trap heat, surface temperatures plummeted. The hydrological cycle that had sustained rivers and weather systems collapsed. What had once been a world of flowing water became a planet where water could exist only as ice. For any civilization that had evolved during Mars's habitable period, these changes would have presented challenges unlike anything faced by human societies. Imagine watching your rivers freeze permanently, your lakes turn to ice, and your very breath begin to freeze in air that grew thinner each year. How would an intelligent species respond to such slow-motion apocalypse? The answer depends on their level of technological development and their understanding of what was happening to their world. If Martian civilizations had developed astronomy and atmospheric science, they would have understood that their planet was dying. They might have spent centuries or millennia developing technologies to survive in an increasingly hostile environment. Underground cities, enclosed atmospheric systems, and advanced water recycling might have sustained them for extended periods, even as the surface became uninhabitable. Archaeological evidence from Earth shows that human societies often respond to environmental challenges with remarkable ingenuity. The ancestral Puebloans built complex cliff dwellings when surface conditions became difficult. The Inuit developed sophisticated technologies for surviving in Arctic conditions. Martian civilizations might have developed even more advanced survival strategies. But ultimately, no technology could have saved them from the fundamental problem. Their planet was losing the basic requirements for life. Even the most advanced underground cities would have faced insurmountable challenges as atmospheric pressure continued to drop and temperatures fell below the survival range of complex organisms. This raises the question of what options remained for a dying civilization on a dying world. Some researchers have suggested that sufficiently advanced doomed, they might have developed space travel capabilities that allowed them to relocate to more hospitable worlds. Earth, during this period, was becoming increasingly habitable. Its magnetic field was strong, its oceans were forming, and its atmosphere was stabilizing. From Mars, Earth would have appeared as a bright blue star hanging in the night sky, an obvious destination for refugees from a dying world. But here's where the story takes a darker turn. Some researchers have found evidence suggesting that Mars didn't die gradually from atmospheric loss alone. Dr. John Brandenburg's analysis of Martian isotope ratios suggests that the planet may have experienced nuclear catastrophes that accelerated its transformation from a living world to a dead one. Brandenburg has identified concentrations of xenon-129 in the Martian atmosphere that are typically associated with nuclear reactions. He's also found what he believes are glass-like deposits on the Martian surface that could have formed from intense heat events. His controversial conclusion is that Mars experienced nuclear explosions powerful enough to contribute to atmospheric loss and surface sterilization. Whether these events were natural, perhaps massive asteroid impacts that triggered nuclear reactions in uranium-rich deposits, or artificial, remains a matter of speculation. But if Brandenburg is correct, it suggests that Mars faced not just slow environmental decline, but sudden catastrophic events that would have made extinction nearly instantaneous for surface life. The implications are staggering. If Martian civilizations were destroyed by nuclear events, it represents a cosmic-scale tragedy that eerily parallels humanity's own nuclear capabilities. It raises uncomfortable questions about whether intelligence and technology inevitably lead to self-destruction, or whether Mars fell victim to some external catastrophe beyond their control. But even more unsettling is this possibility. What if some Martians survived the catastrophes that destroyed their civilization? What if they found ways to preserve not just their biological existence, but their knowledge, their culture, and their identity across the vast stretches of time since Mars became uninhabitable? This leads us to one of the most controversial theories in astrobiology. The possibility that life from Mars didn't just survive the death of its home world, but found a way to than pebbles, others the size of boulders, begin a lonely journey across the void of space. Unknown to the cosmos, some of these rocky messengers carry within them the most precious cargo imaginable, the seeds of life itself. This isn't science fiction. This process, known as panspermia, is not only possible but has already been proven to occur. We've found dozens of Martian meteorites on Earth, identified by their unique chemical signatures that match the atmospheric composition measured by Mars rovers. If rocks can travel from Mars to Earth, then life can make the same journey. The question isn't whether biological material can survive the trip. Experiments have shown that certain microorganisms can remain viable in the vacuum of space for extended periods, especially when protected inside rocky shells. The question is whether this process actually seeded Earth with Martian life billions of years ago. Consider the timeline. Mars may have become habitable before Earth, developing oceans and stable climates, while our planet was still being bombarded by asteroids during the late heavy bombardment. If life evolved on Mars first, it would have had hundreds of millions of years to develop complexity before Earth was ready to support biology. When Mars began losing its atmosphere and surface water, any life that had evolved there faced extinction. But asteroid impacts, the same catastrophic events that threatened Martian life, also provided an escape route. Each major impact would have launched millions of rock fragments into space, and some fraction of these would eventually intersect Earth's orbit. The early Earth that received these Martian visitors was a very different world from today. Its atmosphere contained almost no oxygen. Its oceans were filled with chemical compounds that would be toxic to modern life, and its surface was regularly sterilized by massive impacts. Yet these harsh conditions might have been perfect for Martian organisms that had evolved in similar environments on their homeworld. Dr. Christopher Chyba of Princeton University has calculated that during the period when Mars was losing its habitability, Earth could have received thousands of Martian rocks large enough to preserve living organisms. Even if only a tiny fraction of these rocks contained viable life, it would have been enough to seed our planet with the foundations of all future biology. This developed beyond simple chemistry, then the organisms that made the journey between worlds might have carried genetic information far more sophisticated than anything Earth could have produced independently. In this scenario, Earth didn't develop life, it inherited life that was already billions of years old. Every organism on our planet, from the simplest bacteria to blue whales to human beings, would be the descendants of ancient Martians who survived the death of their world by accident, preserved in rocky cocoons that drifted across space until they found a new home. Some researchers have taken this idea even further. Dr. Francis Crick, who discovered the structure of DNA, suggested that life on Earth shows signs of being too complex, too quickly, to have evolved independently. The sophisticated genetic code that underlies all terrestrial biology appears to have emerged without the long developmental period we might expect from purely random processes. If life arrived from Mars already carrying advanced genetic instructions, it would explain why complex cellular mechanisms appeared so early in Earth's history. Instead of starting from scratch, terrestrial evolution began with a head start. Genetic software that had already been debugged through millions of years of Martian evolution. But the panspermia hypothesis raises questions that are even more profound than biological inheritance. If complex life traveled from Mars to Earth, what else might have made the journey? Could information itself, knowledge, memories, even consciousness, be preserved in ways we don't yet understand? This brings us to one of the most controversial ideas in astrobiology, the possibility that what we call instinct or genetic memory might actually be inherited information from our Martian ancestors. The behaviors that seem to come naturally to life on Earth, the patterns of growth, reproduction, and survival that appear to be hardwired into biological systems, might be the preserved wisdom of organisms that evolved on a completely different world. Consider how certain species on Earth demonstrate knowledge they couldn't possibly have learned from their environment. Monarch butterflies navigate thousands of miles to locations they've never seen, following routes that haven't changed in millions of years. Sea turtles return to specific knowledge that seem to emerge without learning. Mathematical intuitions, artistic sensibilities, spiritual yearnings that appear across cultures without obvious environmental triggers. What if these universal human characteristics aren't products of terrestrial evolution, but inherited memories from beings who once gazed up at Earth from the surface of Mars and dreamed of crossing the void? If this is true, then our deepest sense of wonder, our drive to explore, our feeling that we somehow don't quite belong to this world, might be explained. We are wanderers because we are descended from wanderers. We look to the stars because we came from the stars. We feel like strangers on Earth because, in the deepest sense, we are. But the implications go even further. If we are Martians, then our return to Mars isn't exploration. It's homecoming. Every rover we land, every photograph we take, every sample we collect is part of a species trying to understand its own forgotten past. And this raises the most profound question of all. If we are the children of Mars, what responsibilities does that give us? Are we meant to simply study our abandoned homeworld, or are we meant to restore it? Chapter 7. Are we the children of Mars? Take a moment to consider your own existence from a completely different perspective. Look at your hand, the intricate patterns of your fingerprints, the complex network of bones and muscles, the remarkable sensitivity that allows you to feel texture, temperature, and pressure with extraordinary precision. Now imagine that every cell in that hand, every molecule of DNA, every instruction for building your physical form, originated not on Earth, but on a world with red skies and 2 small moons. This isn't mere speculation anymore. It's a possibility supported by growing scientific evidence and embraced by researchers who once would have dismissed it as science fiction. The theory that life on Earth originated on Mars, that we are, in the most literal sense, Martians, has moved from the fringes of scientific speculation to serious academic discussion. Dr. Stephen Benner, a biochemist at the Westheimer Institute for Science and Technology, has presented compelling evidence that life could not have originated on early Earth. The chemical conditions on our planet, organic molecules could form and stabilize. Benner's analysis suggests that the building blocks of life, particularly the RNA molecules that may have preceded DNA, could only have formed under Martian conditions. If he's correct, then life didn't just accidentally travel from Mars to Earth through panspermia. Life had to come from Mars because Earth couldn't have created it independently. This revolutionary idea is supported by other lines of evidence. The isotope ratios found in the oldest terrestrial rocks show signatures that are more consistent with Martian chemistry than with what we'd expect from early Earth processes. Some of the mineral compositions in ancient Earth formations match what we now find in Martian meteorites, suggesting that significant amounts of Martian material were incorporated into Earth's early geological development. Even more intriguingly, the genetic code itself shows signs of being too perfect to have evolved randomly on Earth. The way DNA stores and transmits information is so efficient and error-resistant that some scientists calculate it's unlikely to have emerged through undirected chemical processes, especially in the time frame available on early Earth. If the genetic code evolved on Mars over hundreds of millions of years before being transferred to Earth, it would explain this apparent perfection. What we see as the miraculous emergence of complex information systems might actually be the result of extensive evolutionary refinement that occurred on another world. The implications extend beyond biochemistry into the realm of consciousness itself. If our genetic heritage traces back to Mars, then our mental processes, our ways of perceiving and understanding reality, might be shaped by evolutionary pressures that existed on a completely different world. Consider human psychology from this perspective. We have an almost universal fascination with the color red, the color of Mars. We're drawn to desert landscapes that mirror Martian terrain. We have an inexplicable urge to explore, to push beyond safe boundaries, to venture into hostile environments where survival is uncertain. Most remarkably, we have an innate sense that we don't quite belong to this world. Every human culture has developed myths about coming from somewhere else, about having fallen from paradise, about being strangers in a strange land. What if these aren't myths at all, but genetic memories of our capacity for abstract thinking that goes far beyond what would be necessary for terrestrial evolution? Our universal spiritual longings that seem to point towards something beyond our earthly existence. If consciousness itself evolved under Martian conditions, shaped by different gravitational fields, different atmospheric pressures, different cycles of day and night, then human awareness might be fundamentally alien to Earth conditions. We might be consciousness transplanted from one world to another, forever carrying within us the imprint of skies we've never seen. This perspective also offers a new understanding of human restlessness and ambition. We are a species that's never quite satisfied with where we are. We constantly push boundaries, explore new territories, and dream of reaching other worlds. If we are descended from organisms that literally traveled between planets to survive, then our drive to explore space isn't just curiosity, it's genetic imperative. The urge to return to Mars, to establish permanent settlements on other worlds, to become a spacefaring civilization, might be the expression of ancient programming that recognizes space travel as the ultimate survival strategy. We're drawn to the stars, not because we're adventurous, but because we're descendants of the ultimate adventurers, organisms that crossed the void between worlds and survived. But perhaps the most profound implication is this. If we are Martians, then we're not just studying Mars to satisfy scientific curiosity. We're studying Mars to understand ourselves. Every discovery about Martian geology, atmosphere, and potential biology is also a discovery about our own deep history. The Red Planet isn't an alien world. It's our ancestral home. When we feel wonder looking at images of Martian landscapes, we might be experiencing something deeper than aesthetic appreciation. We might be feeling the recognition that comes from seeing the world where our consciousness first emerged, where our genetic instructions were first written, where the long journey that led to human civilization actually began. This brings us to our final chapter, where we explore what this means for humanity's future and our relationship with both worlds that have shaped our existence. Chapter 8: The Search for Our Forgotten Past. As we near the end of our journey through this profound possibility, it's time to consider what it means if humanity of our own story. NASA's Perseverance rover is currently collecting samples from Jezero Crater, an ancient river delta that may contain fossilized evidence of Martian life. These samples, which may be returned to Earth in the 2030s, could provide the first definitive proof that life existed on Mars. But more than that, they might provide evidence of our biological connection to the Red Planet. If Martian organisms share genetic similarities with terrestrial life, it would be the most profound discovery in human history. It would confirm that we are not alone in the universe, not because we've found alien life, but because we've discovered that we ourselves are the aliens, transplanted from one world to another by the cosmic accident of panspermia. The implications for our future are staggering. If we are Martians, then our current efforts to establish permanent settlements on Mars take on deeper meaning. We wouldn't be colonizing an alien world, we'd be returning home. The technological challenges of creating sustainable habitats on Mars, of learning to extract resources from its soil and atmosphere, of adapting human biology to its conditions, become not acts of conquest, but acts of restoration. Dr. Robert Zubrin, aerospace engineer and president of the Mars Society, has long argued that human settlement of Mars is not just possible, but inevitable. If we accept the possibility that we originated there, his vision becomes even more compelling. The terraforming of Mars, the long-term project of restoring its atmosphere and surface water, wouldn't be environmental engineering, but environmental restoration. Returning the planet to conditions it once knew. But the search for our Martian origins also raises disturbing questions about the fate that awaits planetary civilizations. If Mars once supported advanced life that was ultimately destroyed by environmental collapse or catastrophic events, it serves as a warning about the fragility of planetary habitability. The isotope evidence that suggests nuclear events on ancient Mars is particularly sobering. If Martian civilizations destroyed themselves through warfare or accident, it represents a cosmic-scale tragedy that mirrors our own nuclear capabilities. The Red Planet would stand as a monument to the dangers that await any species that develops advanced technology without the wisdom to use it responsibly. Panspermia, then our expansion to other worlds isn't just exploration. It's insurance against the possibility that history might repeat itself. The search for Martian life also promises to revolutionize our understanding of biology itself. If life evolved independently on Mars and then mixed with terrestrial evolution, the genetic heritage of Earth might be far more complex than we realize. We might carry within ourselves not just the history of one world's evolution, but the combined evolutionary wisdom of two planets. Dr. Craig Venter, the genomics pioneer who first sequenced the human genome, has suggested that if we find Martian life, comparing its genetic code with terrestrial organisms could reveal the fundamental principles that govern all biology in the universe. We might discover that certain genetic solutions are so optimal that they arise independently on different worlds. Or we might find that all life shares common ancestors that predate the formation of our solar system. The psychological implications are equally profound. If we are Martians, it changes our entire relationship with the cosmos. We are no longer creatures confined to one world, but beings whose heritage spans multiple planets. Our sense of identity, our understanding of our place in the universe, our responsibility to preserve and spread life, all of these would be fundamentally altered. Children growing up with the knowledge that they are descended from Martians would see the universe differently than any previous generation. Space wouldn't be a vast, empty frontier, but an ocean that their ancestors once crossed. Other planets wouldn't be alien worlds, but potential homes where life might once again flourish. The search also raises questions about what we owe to Mars itself. If the planet once supported not just life, but possibly intelligent civilizations, do we have an obligation to preserve whatever remains of its biological heritage? Should Martian exploration be conducted as carefully as archaeology, with respect for what might be humanity's most important historical site? Some researchers have suggested that Mars might still harbor life in its deep subsurface, in underground aquifers, or in protected environments we haven't yet discovered. If we are descendants of Martian life, then these organisms would be our most distant relatives, biological cousins who never left the home as biological. They might have developed forms of consciousness, communication, or intelligence that operate by completely different principles than our own. If such beings exist, first contact wouldn't be with aliens from another star system, but with our own distant relatives who remained behind when our ancestors began their journey to Earth. The reunion between Martian and terrestrial descendants could be the most important event in the history of both worlds. As we conclude this exploration of humanity's possible Martian origins, we're left with more questions than answers. But perhaps that's appropriate. The greatest discoveries in science often begin not with certainty, but with wonder. The possibility that we are children of Mars opens up new ways of thinking about life, consciousness, and our place in the cosmic story. Whether or not we ultimately confirm our biological connection to Mars, the search itself is transforming us. We are becoming a species that thinks beyond the boundaries of one world, that sees ourselves as part of a larger cosmic community, that accepts responsibility for preserving and spreading life throughout the universe. If we are Martians, then our return to the Red Planet will be the completion of the greatest circle in the history of life. A journey that began with desperate survival and ends with triumphant homecoming. If we are not Martians, then our exploration of Mars will still be one of the greatest adventures in human history, expanding our understanding of life's possibilities and our own unique place in the cosmos. Either way, as you drift off to sleep tonight, remember that you are part of a story larger than Earth, older than human civilization, and more wonderful than any science fiction ever imagined. Whether you are descended from ancient Martians or from purely terrestrial origins, you are a conscious being capable of contemplating your own existence and wondering about your place in the infinite universe. And that, perhaps, is the most Martian trait of all. the ability to look up at the stars and dream of crossing the void between worlds. Sleep well, fellow travelers. Tomorrow, the search for our cosmic origins continues.